Well, we got a 16 pill on the healing bench here today. Let's see here. My note is from Mr. D. Now I've got 2 boxes from Mr. D. I got this 16 pill plus another one that I really want to buy, and I only want to buy it because of sentimental reasons. I'll show it to you if I can remember at the end of the video here. Okay, so the note that he sent up here with it. 1 pill open, included it, 100 ohm resistor on that, turns for an output transformer bad. Blah, blah, blah. 100 ohm resistor on that, plus, or no, 100 ohm resistor on that transistor and output I know that says transformer bad. I have pictures of before. If that helps, no, I'm good. Also included a good transistor just in case. Okay, so I talked with Mr. D on the phone this morning. Nice guy, super nice guy. We're not too sure what he wants to do. If he wants to put this thing up for sale, or if he's just wanting to have it repaired and he keep it. So we're a little on the fence. So we're going to approach this kind of from I might keep it point of view, and what do we got to do to make it so it's going to be totally kick-ass if I do keep it, but I might end up selling it, so let's go ahead and give it all the full love that you can possibly give it. That way, if I do sell it, I can maximize my money out of it. These are real deal Toshibas. And this is just the way Fatboy used to build back in the day, short the 5 ohm resistors, or 5 watt resistors, 100 ohmers. So you put 5 watt 100 ohms here, 5 watt 100 ohms here, and 5 watt 100 ohms here on the output combiner. One of these has gone unstable at some point. I'm assuming it's in this section here, just based off of the part numbers. He's showing that this has got a gain of 26, it's got a gain of 24, it's got a gain of 22, and that's got a gain of 22. So he did it right. He took a transistor and had it matched the gains, found a transistor would match. We're looking at the lot numbers on the transistors here. We're seeing 9J, 9J, and then 5F, or 5E. 5E and 5E. And the rest of these are 9Js. So we know our problem was here in this section. First off, let me say good job. I mean, I'm seriously saying this, good job. Because I see people that try to do their own repair work, and the number one problem they have is they don't have a hot enough soldering iron, and it looks like chicken poo around the transistors. You did good job. There's some little tiny solder flick that's down in there that I'm going to dig out here in just a second with a dental pick. But all in all, really good work. You put everything back the way it was supposed to be. Everything is soldered up the way it should be. I mean, it's hot. This hot tits. It looks good. There is some solder work in here that I think is a little questionable, like this over here. Focus. Focus. There we go. We got some solder work throughout that's a little questionable. I've seen this capacitor trick done before. I'm guilty of it when I see it, and I see some little bit of noise in the spectrum analyzer. Some of the tricks that you can do is in some situations, most of the time you don't need to do this. You can throw a capacitor on the output transformer, and it helps snub a little bit of that noise to ground. Yeah. All in all, this box looks pretty good. I mean, it really does look pretty good. Not a big fan of this, as we all know. So we're probably going to end up changing the power wires in this thing. For a short while, they did build like this. Instead of taking a piece of wire and wrapping it around a piece of ferrite, they'd use an inductor like this. Well, guess what? Inside of this thing that looks like a resistor, it is not. Its color is different, and its color band indicators are completely different. This is an inductor. There's a little tiny monofilament piece of wire that's wrapped around a little tiny piece of ferrite that's got 2 leads glued into the end of the ferrite in an actual orientation. That means it comes out of both ends. So you got your inductor in the middle. Then you got an actual lead that comes out of both ends. or shorted to ground. And you know, the way we all do it today is we use just a piece of ferrite and a couple passes through the ferrite, and we'll short from the input transformer to ground. And that gets us our Class C operation, 100% reference to ground. And then we can start playing around with other cool stuff where you do negative bias, which really comes in handy if you're super volt in a box. Which is a trick that I'll get into some other day. That's just another shootout trick, tip and trick that I'll throw out there some other day, where you can apply a negative voltage to certain components inside the box, usually with like a 9-volt battery or something small like that. And it buys you a couple extra volts of headroom of operation in the transistor, and the transistor performs differently too. I'll explain that some other day. That's not what we're going over here today. So what we're looking at is the overall look at the box. He did the repair himself. He goes, I just, one, don't have a big enough power supply for me to check this thing out, and two, I'd rather have your, you know, my little limited amount of knowledge that I have in my humble little mind, take a quick look at it, make sure everything is good. It's got a key indicator LED up here in the front, which is tied to the keying circuit back here at the relay, which is kind of a cool trick because this serves a dual purpose. Your light emitting diode, remember the term diode in the LED portion, will also act as a field collapsing snub diode. As I covered in one of the previous videos, I think it was Mr. H's Repair Part 3, where I added a diode, an actual diode across the legs of the relay. As the coil latches up in here, it pulls a large amount of current and some voltage, creates a magnetic field. Well, when the voltage goes away, otherwise the transistor shuts off, and it's time for the relay to uncouple. One, you have the electrical field that's generated from the armature demagnetizing, and in some relay functions there's an actual moving slug of metal. It'll cause a huge voltage spike, relatively huge to the transistor, and can wipe out the keying transistor. So you'll see on some relays that you can buy off the interboob now, especially like 12 volt, the 10 amperes, you'll find that they'll have a little resistor in it and an LED across the leads. It's not just so it looks cool and give you an indication that the amp's keyed. It's there as a snubbing device to help dissipate that energy from when the relay's field collapses. So that keying LED is actually a good thing. Most boxes today, we just put a little actual, you know, couple hundred volt, maybe quarter amp or half amp or an amp diode across the input of this thing. I mean, you can use a 10A10 if you wanted to. It not necessary. It leaks that voltage down. It doesn't zip back and freaking flap out the keying transistor. This I'm not too hot of a fan of. This tuning tube is actually movable. I want my tuning to be here today. No, how about let's go over a bump and take a tight turn, and now my tuning's over here today. So we'll have to address this. We'll probably move this away from the combiner ring and the output inductor coil, and we'll probably move it up here on the lid someplace. There's a piece of packing tape, as we can clearly see, covering this hole. This was initially where the power wire was supposed to come in. It was here. We'll probably put a grommet in there, you know, like a body bung of some kind. And then, even though it doesn't hurt anything to not have a grommet on this lead, we've got to have a grommet on this lead. We want to maintain the cable's integrity, because we could rub through the cable and then we start cutting wires, and then we're going to have you know, a little bit of current loss. So I'll probably disassemble this and I'll sneak ourselves a grommet in here, make it all nice and visually pretty for down the road. But all in all, then I got to blow it out with an air compressor. All in all, for as old as this box is, there's no corrosion on the cabinet. There's no corrosion on any of the boards for the most part. I mean, there's little tiny speckles of it, but nothing like what I normally see. This amp looks really good. I mean, it looks really, really good. I'm not a big fan of these caps that are in here. These are Russians. These are Russian-made caps. They work okay. I've had them fail quite a bit, though. So it wouldn't surprise me any that when we go to fire it up that maybe this cap has got a problem with it, and that's maybe the whole reason that this circuit failed. We don't know yet. We'll find that out when we get a little bit down the rabbit hole on this thing. And then last but not least, let's go look up here. What we have here is a stock JMC fan back when they were really good. Another stock JMC fan one back when they were really good. Another stock JMC fan, and then a modern JMC fan. JMC made really good fans for a lot of years that we used in the RF world a lot. But there's a huge difference between that fan and this fan. And none of it has anything to do with the CFM, has anything to do with the blade count, has anything to do with the RPM. It all has to do with this electronics that are in here. The electronics that are in these older fans, the components in them are different and the RF didn't affect them. The new JMC fans, I used these a lot for a lot of years, and now I've gone and I use Sun-On, because the Sun-On circuitry has a tendency to put up with the RF environment that they're being exposed to. Like if I was to put 4 modern JMC fans in this thing and I put this one, I had a modern JMC fan that was right over the top of this output network. Usually the first time I would key, the RF will saturate this circuitry, and then it's going to send an electrical pulse back through the entire thing, and it'll wipe out the other 3 fans. This fan quit, it's been replaced, but it's not even been hooked up. But it has been heat shrinked and has been capped off. Oh shoot, did I damage my bird meters? I did not. Has been capped off, and then it looked like at some point or another somebody has taped it off. See the tape coat there? And that tape is now, as we can see, checkered. Which means we'd play hell getting this off. I mean, we'd play hell getting that tape off of there now. So, what we worked out is that if we put and lift the ground on this fan, number one, then we take a piece of aluminum duct tape. It's basically a piece of Kapton. I got a big ass roll of it around here someplace. I know I do. Ah, here it is. I haven't had to use this very much lately because I switched over to the Sun-Ons, but it's basically a layer of Kapton with some adhesive on it, and then an aluminum backer. This aluminized tape. If we put this over the electronics on the fan, it hardens it enough where it'll put up with the RF environment. Otherwise, it might fail. And it might work great on the workbench, and then you put it in your truck, and then there might be a little electrical or RF spike or something, and it'll zap that fan. So we figured out by hardening it, by putting the ferrite bead on it and throwing the inductor that comes off of the fan, throwing it out of resonance with the RF and creating a choke, lifting the ground and creating a separate ground potential, just with a little bit of a resistor that also acts as an RF choke in its own right, changing the ground reference, the choke, and putting a little piece of aluminized tape on it. We've had pretty good success in making these work and stay working no matter what you do with the amp. So, okay, we got the initial start out of the way, and the other thing we got to do is we got to add up the total amount of ampacity for each one of the fans. Okay, now this is a pre-running amp. We know it's been working like this for decades. Would assume probably 10 years. 0.6, 0.6, 0.6, 0.6. So we're looking at about 2-ish, 2.4 amps total. So 1.2, 1.2 is 2.4 amps-ish with the current draw going through here. And also you got to think about that the remote's got to carry that amount of current too, and then the remote lead and all that kind of stuff, but I think we're good. I'm not going to worry about that too awful much. So let's blow it out with an air compressor, and then there's a tiny little piece of flick down here that I want to get. Come on, Luke, pay attention. There's a tiny little piece of flick of solder schmoo that's right there, and you can see it from here. A little tiny glob of solder where it's dripped over and it's made contact with board ground. So it means any RF that comes in is going to go straight to ground. We can't have that. That'll throw everything out of whack. So let me blow this out with an air compressor. Maybe I'll be able to blow that out with the air compressor, and I won't even need to dig at it with a dental pick. But all in all, solder work around the transistors and the work that you did, young man. And I say young man, assuming that you're younger than me. You sound like you're younger than me on the phone. I have no idea. Don't really care. I'm just saying. Good job. Looks good. I gotta take my headset out of my ear. I got my phone on silent today. Every time I pick it up, you've missed 4 phone calls. And that connector is tight, like it's brand new. I mean, so is the output one. Okay, we blew this out with an air compressor. Went ahead and repaired the fan fully. Put some Kapton nylon duct tape on there. Aluminized tape, put that on there. Put a resistor on it. Put the choke on it. So now we have 4 functional fans. Yay! So what we got going on over here is this is our hot lead over here. And this is our ground lead. The reason it's red is because, well, these are both males. And I don't care how you identify in this world, if the knobby bit goes into a hole, that means male. Both of these connectors are male. So I have multiples of these welding leads laying around here, obviously. And I have one set up for female and another one set up for male. Or no, they're both set up for female. So what most people do is they'll have a male here and a female here. Then on the ground side, they'll have a male here and the female over here. And the reason we do that is so there's no chance, no chance of us, or I guess it'd be that way, no chance of us hooking it up backwards. And every time I got 2 red leads and I go over here towards anything for the power system, it makes me cringe and I wince and I go, Jesus, take the wheel. So we went ahead and we disconnected this connector, pulled it off, pulled the wires through the cabinet, put a grommet on here, pushed the wires back through the cabinet and put the eyelet back on it. And then, oh yes. I don't want to drop this. I went in with the dental pick edge, the L pick A. And I removed the L solder flick A. A little tiny shit like that is just enough to make this whole thing not work. Believe it or not. I was working on a box the other day and I was out there rummaging around and I had the dental pick out and I'm picking on stuff. And it still had caps hooked up and it went spap! And it took and disintegrated the whole tip of my dental pick. So yesterday I went out and I bought a whole myriad of new dental picks because I've burned through about 4 or 5 in the last year or so. Okay, so we got new dental picks. I covered that. Let's quit mucking around here. Zip this thing out. Let's go ahead and, okay, no arcing, no sparking. Yay. Come on, get, there we go. All right. Let's see if the lights turn on the front. When the lights go out in the city. Okay. That brings me hope. Let's turn this on. We'll put that on 1X. Turn on the bench 2950. Amp is off. Hello, 1 2 1 2. So we got a good pass-through tune. I don't think we're gonna have to do much to this box, to be honest with you. Hello, 1 1 1 1 1 1. So, got a good pass-through tune. Let's set that up so we're right on the watt meter. It's a 1,000 watt slug and peak, 1,000 an average, 5 watt slug and reverse. Back from the bird, 10,000 watt dummy load. Hello, 1 2 1 2. Pulling 60 amps worth of current. Putting just a few watts of drive into it. Let's bring our FLIR online. There's no reason to torture ourselves here. Measure, there we go. That all looks good. Output resistor. Looks good. Final combiner stage. Looks good. Hello, audio, making 300 watts of power. Hello. Let's look at our input tune, which looks really good itself. Hello. means it wants more drive. It means it's happy as frig. Okay. So, brother, I gotta tell you, your repair works fine. Let's go down here and turn on the power supply. 14 volts, 14 L volts, 15 L volts. Hello. You see the difference between 15 volts, 15.5, and 12 volts? We're seeing 300 watts of power. Hello, audio. Hello, audio. Now we're seeing 800. Hello, 1, 2. Okay. Okay. Yay, now we got some results. Check this out. Now what we're seeing here is the output combiner ring itself, the whole ring, all 4 of these resistors here are heating up evenly. Now, if everything's in tune, these shouldn't heat up at all. Remember how I was talking about our movable capacitance tube over here? Let's slide that out a little bit. Hello, audio, 1, 2, 1, 2. So we're still getting our 800 watts of power over here. Hello, 1, 2, 1, 2. No, that's not happy either. Let's take it to about halfway. Hello, 1, 2. Hello, 1, 2. Still picking up a little bit of heat. Let's slide that tube in a little bit more. Hello. There we go. Okay, so to save all you guys in YouTube land a lot of painful waiting as this thing cools off, okay, all of our resistors are at about 72 degrees now. Let me take a quick little screenshot. I'll insert it in here. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2. And we'll take another measurement. I think that was 72.5. It's still not 100%, but it's closer. Now, let's check one more thing. These little wire inductor things kick ass. But when they go bad, sometimes there's no way to be able to tell that they're open. So what I want to do good. 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 That's pretty good. That makes me happy. Everything's going to turn out well, and all the girls are going to dance at the same party together. Hopefully we can get them drunk, and maybe they might take their clothes off if we ask them nicely. All the girls I go with, that makes them happy, so we're working. I'd like to slide this in some more and see if we can get rid of some more of that heat. But so the heat shows up when the output network isn't perfectly in resonance. So the transistors are going to make the power. They don't care. They're just turn on, do their job. And if the circuit that is attached to the transistors isn't resonant to the component, you're going to see heat build up, usually in the flybacks or input, or if the circuit's not in resonance with the rest of the other 4 stages, because there's 1 stage, 2 stage, 3 stage, 4 stage. There's 4 amplifiers in here. But really the way you got to look at it is that there's 8 2-pills. So 2-pill amp, 2-pill amp, 2-pill amp, 2-pill amp. One's pushing, the other one's pulling. Okay? They turn into... If the RF isn't in resonance with this coil, either it be the length of the inductor or the amount of capacitance to bring it to the 50 ohms where it needs to be to hit the coax and go out the tube, okay, you're going to see heat. These will get hot. But with air blowing on them, even if this is slightly out of tune, it's not going to be enough to burn these resistors. And that's what we've achieved now. We've got it to where we run the box and the resistors heat up maybe 0.2 of a degree. Okay, and you want to have that at 0 is ultimately the thing. Usually what will cause these to burn up is one of these caps will devaluate, or you'll lose a transistor, one of the sections will fall out of balance, and this will burn. Okay, it's trying to suck up the imbalance. Okay, everybody's got that? Good. The reason that we have that reflex slug is because I know for a fact that everything that we're putting in this thing is going into the dummy load and nothing is coming back. If stuff was coming back from the dummy load, like in the real world on an antenna, if you had too high of an SWR, too much reflected power, standing wave ratio is wrong, okay? It's not resonant, high SWR. It'll come back and it'll heat these resistors up and burn them up. They'll get hot. Very rarely is that the issue though. 9 times out of 10, the reason this stuff burns up is because something over here quit. And because a lot of guys don't run watt meters, instead of using a 2-watt resistor here, we use 5 because it generates more smoke and it can dissipate more heat, and then when there is a problem, it can actually save the other parts. It can give you 2 or 3 keys where you're not going to negatively affect the beta gain or drag down the other sections, but it produces more smoke. And if it was me, I'd put 20 watters in there, but I can't figure out a way to get the 20 watter to sit in there or 300 watter to sit in there and then not take up a bunch of space and flop all over the place and be a bunch of extra weight. And then add a bunch of inductor to it and stuff. It's, 5 watts is about as big as we can go safely and make it work well. That's the reason I like using them. And I like to use them in the whole box. 1, it looks really cool, and 2, if there is a failure, it's going to dissipate more heat, protect more components. Bob's your uncle. Let's drive this a little harder and let's see what it does. Okay, so we got our 955 hooked up now. Hello, audio, about 85, 90 watts. Hello, come in. Hello, 1, 2. All right, we're pinning that in the corner. Hello, audio, 1, 2. Hello. 1400 watts. Let's see where we at here. 1400 watts. Now let's look at our combiner ring. See, now we've achieved resonance. Everything is happy. Look at that picture. Nothing's getting hot. Nothing. It's a pure day. Our input SWR had 01212. 2 bars on the striker and a 1/4 watt on the 5-watt slug. All right, well, when in doubt, drive it harder. Okay, so I got the Godzilla box. It's the one that's got like 9,000 little caps in it. And I get flack for this. So don't want to put on stupid caps in it, because it makes it work better. I mean, with the advent of the super cap, you don't need to do any of that anymore, but super cap tech hadn't been invented when I built this box. So let's go over here. Let's show you drive. This is radio. Hello, 1 2 1 2 1 2. About 25, 28 watts. Godzilla 2x4. Hello. Pin it in a corner. We'll go up to 2x now. Hello. About 13 and some change, 1400 peak is what we're going to put into this thing. Hello. And with this radio driving this amplifier, hello, about 400 bird. Okay. Let's take this up and turn the 16 pill on. We're going to take that down to 5x. So now the needle, when it's fully deflected to the right, we're reading that center scale, the 50, the 40, the 30, the 20. You're going to add 2 zeros to that. Hello, audio. Hello, audio. And this is where we're going to have a failure if we have anything. We are falling short on power. Seeing 35 out of it on 15 volts solid. And only 800 bird. Audio. There we go. Audio. Audio. So nothing's falling in imbalance. Let me zoom out so you guys can see what I'm doing. I'm slightly adjusting this output tuning tube to see if we can get it to pick up another couple hundred watts or not. It is not. So let's go ahead and we'll bring a voltmeter in line and let's see if we got a bunch of current loss someplace. Because I'm feeding 15.9 in this. We're going to have some voltage sag take place here. There ain't no doubt about it. Hello. Yep. Hello. There's our 4 grand. Hello. Hello. Audio. Hello. All right. Let's take a look over here at our amp meter. Hello. 400 and something amps. So about 310, 305, somewhere in there. Minus the 2x4. Yeah, it's fun, isn't it, you guys? I'm telling you. 305 times 14.75. 4,498 watts worth of consumed input power times 0.60. That math doesn't even remotely add up. Times, say 375 then. 5,625 watts times 0.60. That's closer. It's about 64% efficient, which isn't the greatest, but it's about normal for a Toshiba. So, it works. Let's take this out of here. Let's take this out of here. So we're all going to remember these reference numbers. Making 3,800, 3,900 watts of power with a whole lot of drive. With a whole lot of drive out of 16 transistors. And we know we got our tune right. Our input tune looks great. Output tune looks great. Combiner ring's not getting hot. But we're falling short. We're falling short a little bit. Let's change some fun stuff. Correctly, our last test was at 16.2-ish volts, and we're driving it with the bench well, the Godzilla box. Had a variable all the way up, and we were using the 2950 bench radio. And we were putting about this much drive in it. Hello, audio, 1, 2. Nope, sorry. Put about this much drive in it. Let's turn on the right amplifier. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Driving the poop out of it. Honestly, between you and me, I'm a little bit shocked that we're not seeing a little bit more than what we're getting out of it. But the first time that we had this up here, it was doing like 35 to 3600 peak on this meter. We're in 5x scale, by the way. So you got to remember, the last segment that you guys watched, to your guys' mind, was just a couple seconds ago. To me, that was 5 hours ago. 50 phone calls and a bunch of BS ago. So now we get to see if any of the changes we made increase our output power. So we did the basic power wire upgrade, not the full blown, just the basic upgrade to it. And the reason we got to do the basic is because I'm not going to lie, I'm out of the Type 61 beads. These little beads were out. I got more coming. They're getting really hard to come by the way. Over here, obviously what you're going to notice, the biggest thing is that we moved the tuning tube from being right up here against the output combiner, which I didn't like, to over here, and it is now mounted to the wall, which gives it a little bit more stable platform to be mounted on, where it was only held down by this one little tiny tack of solder before, and was able to float freely. I did not like that. So we attached it here, give it 2 firm, hard-mounted points of attachment to the case, and it takes it away from the combiner. We don't have to worry about anything moving around and getting bumped into or touched. I don't know where I put it. Here it is. Here it is, just out of frame. That was our old output inductor coil. So we built a new one, and that allowed us to fine-tune the output just a little bit. And honestly, that's where we picked up most of our power. Really did. Is from here. Picking that up, just changing the inductor a little bit. So now, if we see anything past here, the 3500 watt mark, that's an increase. We're going to count that as a positive gain, okay? So let's make sure our voltages are right first off. Let's drive the brakes out of her, Batman. We're definitely seeing more bird, or more peak and more bird. So, and the voltage, we're at 14.9, right? It's about where we were at before, if not a little bit lower, like 14.8, 14.9, somewhere in. 1, 2, 1, 2, 1, 2, 1, 2. Now we're not falling short now. We're falling short, and it was anemic to me. It's like, no, I want it 16 transistors. I want to see 4,000 peak and well over 1,000 bird with this radio hitting it. We're seeing about 41, 4,200, which is about where we want to be. And under that old Model T was a place she first showed it to me. You see how easily it's jumping up there now? It just wants to go up. Oh, RF getting in the mic. Hold on. Look at this. Let me stand a little bit farther away from the box. I'm sorry for being so close to you, beautiful. All right. Run our dead key down a little bit then. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2. Okay. Now, let's change this around a little bit. Let's have a little bit of fun here. We're going to get rid of the 1,000 watt slug. And we're going to put in the, see if it's even in frame here. $5,000 watt slug. Okay. And I really want to drive this home. I'm really tired of people saying, oh, but mine does more bird watts than yours. I don't care. You got a different radio than I got on my workbench. Who gives a shit? Let me prove it to you. Once again, I'll step this back and bring this forward. So now we can see all the different parts of the equation. The driver, the final stage, the volts, the watts and peak, the watts and average. Right about 1,000 in bird. I'm going to disconnect the coax. Okay. And now I'm going to hook up the derail Cobra 29. Let's see how many bird this does. Shut off the bench 2950. Grab the Cobra 29 derail radio, does the same amount of watts. Well, that stinks. We just killed a pill. Damn it. Must have overdone it. But it was making 3,500 bird there for a second. Well, I seen something there that I didn't like, so I thought I'd check it. Let's go ahead and let's put the cabinet on this thing and get some air moving on it. Strip out some of the heat. I got the voltage dialed way down on the power supply. There's no point in us juicing it like that. We're just going to end up blowing something up. Let's get the cabinet screwed down so we got a good ground. All right. That's enough screws for now. Microphone, no! Sorry about that. Microphone got caught up on the tripod for the giant camera that I use. Okay. This is our new fan. Or is it this one? It's this one. And let's see. Hello, 1, 2, 1, 2. All right. Hello, 1, 2, 1, 2, 1, 2. Fans are still all turning, nothing slowed down. I run on 14 volts, 14.8. This means the amp's running on 13 some change inside the box. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Bring a carrier up just a hair more. Hello, so it'll stay latched in between the words. Hello, 1, 2. Hello, 1, 2. Now we're banging the crap out of that 1,000 water. Let's put the 5K in there. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. This thing's done. 4,000 watts. No problem. I'm happy. I should not have. This thing had a blue fan in it, one of them blue never cools in it. And I put one of these giant 3-inch thick bastards on there, or 1.5-inch thick bastards on there. There's one loud SOB. Well, it's working. It's working good. It's got every little bell and whistle in it now, for the most part. I think this thing's ready to come home. Dude, you did a great job repairing this, by the way. Just wanted to say that out there publicly, that you should have more confidence in your skills, because you did good. You did just fine. And I don't see anything in here that's giving me any cause for concerns. All we basically did was get the fan right, get the output tune right, which I got to go in and lock that tube down now. Just we've been keying the crap out of it and it didn't have any air on it. We needed a grommet and it needed some of this and a little bit of that, but no big deal. I mean, literally no big deal. So you should be proud of yourself. You did good. You did real good. We're done. Sorry, it's been a long day. My brain is toast. The phone has rang a lot. Tomorrow I think I'm working on a 2x4 Hornet, which I've never even heard of before. But I'm done. I'm gonna go give my goddaughter a hug at the airport as she goes off and gets on the airplane to go back to Hawaii, and I'm gonna come back here and hang out with my wife. But we're done. This thing is running rape ape. I don't need to touch it, don't need to do anything more to it. So now, this is where I normally sign out. But I'm gonna pause for a hot minute because you told me you didn't know what you wanted to do yet. If you wanted to sell this thing, or if you wanted to keep it. So I'm gonna set this aside. I'm gonna give you a call. We're gonna talk about your options. Hopefully you've made up your mind. And hopefully this is coming back to you. We'll see how this wraps up. Maybe we'll put it up for sale. Maybe we won't. In the next little segment, we'll find out together. Well, you guys are in luck. This guy has decided that he wants to sell this thing. He said he wants to get 3,500 bucks for it. And I think it's worth it. I am going to say that there's a little dent back here on the air guard. Like right here. That's it. That's the only exterior cosmetic damage. And as you all know from spending the last hour or so looking at the inside of this thing, we all know it's pretty freaking straight. So, yeah. We all know how to get a hold of me. Call the number. Shoot me a text. But this thing is ready to go. 16 pills, Toshibas. All real deal, legit, non-red dot Toshibas. Give me a ring. We'll see ya.